Creating a data layer with JPA. In this section, we'll learn about creating a data layer with JPA. We'll cover data access in Java 9 and Java 8, and we'll look at JDBC and JPA before we create a data layer for our marathon entry system. Data access in Java. In this video, we're going to learn about data access in Java, and specifically we'll look at JDBC and JPA. We'll also be looking at enterprise JavaBeans. JDBC, or Java Database Connectivity. As the name suggests, it's used for a standardized database access in Java applications. It provides a common database access API, so access code written for one database can be used to access another database simply by changing the driver. It's a bit more complicated than that, as you have to ensure you're using ANSI SQL standards and no database-specific features. JDBC supports DDL and DML and has mappings for data types to Java types, so varchar maps to string or integer maps to int or integer. We also have support for database transactions, and we can pull JDBC connections, because when you start studying performance you realise that the most expensive part of communicating with a database is the actual connection. Here's a JDBC example. Here we have the data source getting injected using resource. We then use the data source to get a connection to the database, and once we've got a connection we can get a statement, and then once we've got the statement we can execute our query. So select forName from app.names where id equals 1. Then we get the result set. We can use result set.next to get the next value, and once we've got that we can say we can just output the name here, so result.getString forName. And with this being JDBC, I could change the driver to point at Oracle or DB2 or Apache Darby, and this should run because it's standard SQL. JPA, or the Java Persistence API. The more you write JDBC code, the more you realise that there's a lot of repeating patterns and boilerplate code, especially as you end up mapping your query result sets to domain objects. This moves us to JPA. JPA is an object relational mapper. It allows you to map your database tables to your Java object model or domain model. It can also create the underlying tables and relationships. It has two query languages, JPQL and the type safe criteria API. JPQL is similar to SQL, but different at the same time, and it allows you to do queries against your structured data model. You can also execute SQL as a native query using JPA. The current reference implementation for JPA is Eclipse 2.2. If we look at our JPA example here, you can see what we're doing is we're injecting the entity manager to our persistence context. Then we create a POJO, so we have entrant equals new entrant, and then we're setting the forName, the surname, the age, and the sex. And then all we have to do is call entity manager.persist, and that will register our object with the database and create a new entry. There's always a lot of discussion over whether object relational mappers are a good idea. So let's have a look at the advantages and disadvantages of object relational mappers, and specifically JPA. The big advantage is that you save time creating your entity model and can focus on business logic. You can also write database independent queries that get translated from JPQL or the criteria API into SQL. The main objections for object relational mappers are object relational impedance. This issue is that database tables are tables, while objects in a programming language are an object map domain model. An easy way to think of this is that a list in your code does not map to a list in the database in the same way. The implication is that there's a trade-off between your database model and your domain model. The application design generally dictates that the entity model overrules the relational model, but in reality it's a series of trade-offs. Another complaint is that generated queries can be inefficient. The solution to this is to handcraft slower queries and use JDBC or native queries on JPA. My own view is that any time I haven't used an object relational mapper, I've ended up writing something similar to an object relational mapping framework of my own, and then you're left with the overhead of supporting it. So my advice is to use JPA where possible, and when it comes to more complex queries, use native queries or straight JDBC to run these queries. The entity manager is one of the key parts of JPA to understand, and it's the main interaction you'll actually have with JPA. The entity manager manages the relationship between your entity objects and the underlying data source. it's worth having an overview of this interaction. The one requirement for our interactions with the Entity Manager is that we need to wrap the interactions in a transaction. There are 5 key stages. The first is null. This is where an object doesn't exist. So it's my object name equals null. The next stage is my object equals new my object. At this stage, it's not associated with the Entity Manager. Then in the next phase, we're actually getting involved with our data source. So we're going to create a managed bean. This is where we call the persistence, the Entity Manager to persist our object. So we'd call the persist method. So persist, and that creates a managed object which is registered with our database. We can also detach from our data source. So if we detach, then we're no longer under the control of the Entity Manager, but our object still exists in the database. And finally, we can remove an object from the Entity Manager or remove it from the database and it ceases to exist. These are all backed by callback methods which aren't shown on the diagram. Enterprise JavaBeans. The previous discussion of Entity Manager stated that we need to ensure calls to the Entity Manager are enclosed in transactions. The easiest way to do this is to use Enterprise JavaBeans or AGBs. The AGBs are normal JavaBeans that are defined with one of 3 annotations. These annotations allow the bean to have access to a range of container services, including Java Transaction API. It's worth noting that although the beans may look simple, it will be wrapped by the container and all interactions will be made through the client proxy controlled by our server. The 3 annotations are stateless, stateful, and singleton. Stateless means that we call a method, then it performs an action, and once this action's ended, our interaction with the AGB has concluded. So in terms of a transaction, the stateless transaction, we would call our method in the AGB, then once we've exited, that would be the transaction over on a stateless bean. The next one is stateful. This means the interaction can span a series of interactions, and the state's managed by our entity Java bean, our enterprise Java bean. And finally, we have singleton annotation. This is a special bean which can be used to share state in a container. As with our coverage of CDI, it's good practice to program our EGBs to an interface, but this isn't necessary, so we could also use these annotations on a class. We'll be focusing on @stateless beans for our service layer, because it's a simpler approach to managing our interactions with the Entity Manager and database. In this section, we've learned about data access in Java using JDBC and JPA. We've covered the Entity Manager and how EGBs can be used to simplify this interaction.